So now let's summarize the importance score findings and compare again back to the in-degree measurement that we had in the beginning. So and here we're showing in each node the importance scores that we got for W 4 over 31, X is 6 over 31, Y 9 over 31, Z 12 over 31. And you can see how they split out. So 4 over 31 goes to 2 and 2, and so on. And then 6 goes to 3 and 3, 12 goes to 4, 4, and 4, and things along those sorts. So here are the equations again that we had, and you can verify that each of these equations are satisfied, right? Because we were using those other equations that we got, the intermediate values in terms of Z, to solve for these importance scores because it was just easier to plug back into them. But you can go back through and say, for instance, W has to be equal to Z over 3, and we said Z was 12 over 31, so 12 over 31 divided by 3 is 4 over 31, which we said is the importance score of W. X is W over 2, which is 2 over 31. This is 2 over 31 plus Z over 3, which is going to give you 4 over 31. So that'll give you 6 over 31, which is X's value here. Now, this equation 2, which we didn't actually use, if you recall. We didn't use this equation for Y here. But it's W divided by 2, which is 2 over 31 plus X over 2, which is 3 over 31 plus Z over 3, which is just going to be 4 over 31. And then that'll give us 9 over 31 for Y, which is what we thought. And Z is X over 2, which is 6 over 31 divided by 2, which is 3 over 31, plus Y, which is 9 over 31, which is going to be 12 over 31. So you can see that each of these equations are valid, exactly as we thought. So they all do hold. So here's a tabulated summary of the difference between the in-degree and the PageRank calculations. The PageRank we're showing on the right side over here, and we see all these importance scores, and these sum up to be 1, and both of them do actually. Both the importance score sides, we sum them up to 1. It just makes it more convenient to look at it that way. And so the rank is 4th, 3rd, 2nd, and 1st. Whereas over here you saw before, W is still 4th, that didn't change, but now the order is a little different for the rest of them, right? So before we had X and Z tying for 2nd, because X and Z both had in-degrees of 2. And we had Y with the highest because it had an in-degree of 3 before. So you can see a difference here. And the way that we're getting these normalized values is by dividing by the total number of in-degrees, so the total number of links basically, just to get them to sum up to 1, right? W is going to have a value of 1/8 because it has 1 out of the 8 links pointing to it. X is going to get 2/8. Z is going to get 2/8, and Y is going to get 3/8. That'll add up to 1. So the main differences from the in-degree, first is that Y is no longer the most important. Okay, so before we had Y being the most important because we said, well, it has 3 links incoming, but it's no longer the most important. And the reason is because now we're taking into account who's pointing to who and how important the nodes are that are pointing to me, right? So the reason that Y really isn't the most important anymore is that Z, which is now the most important node, is spreading only 1/3 of its importance to Y, right? This 4 over 31 that it gets. And it's only taking half from W and X, which are like the middle important nodes. So it's not even getting their full importance. So it's aggregating importance from everyone, but it's only getting a small piece of that importance. All right, and particularly with Z being the most important node. And now, why is Z the most important node? Well, Y we said is the second most important now, and Z is going to get all of that importance score, 9 over 31. All of it, because Y is only pointing to Z. So when you land on Y, the next step has to be to go to Z. And it's also getting some from X, right? So it has to be greater than Y. It has to be more important than Y, because not only does it have all of Y's importance, but it has something a little greater. So we can see already that Z needs to be greater than Y in importance, and that's why that's the case here. And really, we should emphasize that, again, it's the importance of the links that are pointing to you that matters, and the importance of the nodes that are pointing to you that matters, because then those links are going to get used more often, and therefore you're going to be a higher importance as your own node. So it's not just the number of links you have in, it's the quality of those links in terms of importance that makes us be able to determine which nodes are important and which aren't. At least in the context of Google, and this is how Google's page ranking algorithm works in terms of solving these equations, in terms of their importance scores. There's many different ways of defining importance, so it's not an easy, clear-cut problem. That's why consensus is hard, because it's not easy to determine what the right answer should be.